If you're on the ground during a thunderstorm, you might witness a spectacular show of lightning. But if you're observing that same thunderstorm from the vantage point of the International Space Station, you might see a bolt of energy shooting up from the clouds, and it might be red, or blue, or even green. These particle outbursts are like nothing seen from the ground and may prove useful to predict weather outcomes more precisely, better understand changes to our climate, and increase the safety of planes and ships approaching dangerous storms. They have names that sound like they were taken from a fantasy novel: Blue Jet, Gigantic Jet, Red Sprite, Halos, and Elves. But all belong to a more scientific-sounding family: transient luminous events, or TLEs. Flashes and glows that appear above storms that are results of activity occurring in and below those storms. Dr. Timothy Lang is a lead research aerospace technologist at NASA's Marshall Space Flight Center. He explains how two key observational instruments aboard the orbiting laboratory are helping scientists better understand these colorful bursts of energy. We use the Lightning Imaging Sensor, or LISS, to map lightning in 2 dimensions with global scale coverage. It shows us where the thunderstorms are taking place, and how powerful each one is based on the size of its lightning flashes. So it's akin to a macro camera. Another instrument, the Atmosphere Space Interactions Monitor, or ASIM, is operated by the European Space Agency. ASIM gives us very fine detail of a TLE's flash. In essence, it's akin to a micro camera. Torsten Newbert, ASIM principal investigator at Denmark's National Space Institute, adds that ASIM and LISS make observations in different ranges of the color spectrum, allowing for different views of these particle events. So LISS is macro, ASIM is micro, and together they provide a powerful combination for exploring lightning and TLEs. The space station offers an excellent vantage point to scientists studying TLEs. At about 250 miles up, it is much closer to these phenomena than a geosynchronous satellite. Further, the station's orbit allows for coverage of storms worldwide. All this allows LISS and ASIM to produce a unique space-based data set of thunderstorms and their effects, which in turn helps support other observational instruments. LISS, for example, has been used to calibrate instruments and verify data for the geostationary lightning mapper on NASA and NOAA's GOES satellites, and will also support the lightning imager on the European satellite Meteosat 3rd generation. This support helps make data produced by these sensors the highest quality for serving the public. From the space station, LISS can provide lightning data in near real time for the benefit of those on Earth. It can report lightning nearing dry areas of forests prone to wildfires. It's integrated into the NOAA Aviation Weather Center's operations, which provide weather forecasts and warnings to the U.S. and international aviation and maritime communities. And over time, it can map data points to help scientists observe changes to our climate over broad tracts of land and sea. In short, studying lightning and its effects both below and above the clouds can have a big impact on how we view our planet. Doing so from the International Space Station is improving that view in ways that couldn't be accomplished anywhere else. For more electrifying information about the International Space Station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.